The Dillon M134D is an electrically powered 6-barreled Gatling gun. It can be powered by AC or DC power sources. The weapon is chambered in a 7.62 mm NATO and may be fed from magazines of between 1,500 and 4,400 rounds capacity. The M134D is a modular system, allowing easy adaptation to any existing platform. This flexibility allows it to perform equally well in the fixed forward fire or crew-served mode. The standard Dillon Gatling gun fires 3,000 shots per minute. That equals 50 shots per second. No other 7.62 mm weapon comes close to this rate of fire. Why is shooting fast important? Because only fast guns such as the M134 can achieve the extreme shot density needed to suppress multiple targets in compressed periods of time. But it is more than just shot density. Fast guns are more likely to hit targets than conventional guns. How much more accurate is the M134? 4 times the number of shots should equal 4 times the number of hits, right? Wrong. Surprisingly, the M134D is, on average, 9 times more likely to score hits. This is true because of the combined effects of high rate of fire, extremely dense shot grouping, and high weapon stability. Traditional gas-operated guns, such as the M240, have comparatively slow rates of fire. This can range anywhere from 550 shots per minute for an M2 heavy-barreled 50 caliber, up to 800 rounds per minute for the M240. These machine guns all utilize a single bolt to feed a single barrel. Their maximum rate of fire is limited by the nature of this design. Each time a single-barreled machine gun fires a round, the gun bolt must move aft to extract the empty cartridge. It then comes to a complete stop before moving forward again. For an M240 firing at 800 rounds per minute, the bolt must complete this cycle 13 times every second. This continuous start-stop motion generates large stress forces that must be absorbed by the weapon, gun mount, and the gunner. Additionally, each shot fired creates large amounts of heat. This heat builds up in the barrel. As rates of fire increase, the amount of time the weapon can shoot rapidly decreases due to the barrel's thermal limitations. Exceeding temperature limitations can lead to degraded accuracy or catastrophic barrel failure. The Gatling gun's high rate of fire is made possible by its unique rotary design. The M134D has 6 gun bolts and 6 barrels. This means each barrel only fires once per rotation. At 3,000 shots per minute, each of the M134's barrels only experience a rate of 500 shots per minute. As a result, the Gatling gun can sustain its fire for much longer periods of time. In fact, the M134 can fire an entire 3,000-round magazine in one burst without risk of damage to the gun. Furthermore, since the M134 gun bolts move in a rotary motion, it is not subject to the jolting vibrations caused by the start-stop motion of gas-operated gun bolts. This makes the Gatling's operation much smoother and easier to control. But there is a fundamental difference between the Dillon Gatling gun and the conventional machine gun that goes beyond rates of fire. It can be understood by examining the philosophy behind these guns. Certain factors have driven the evolution of the machine gun. Foremost among these has been portability. Ever since Hiram Maxim created the Maxim machine gun, the machine gun has primarily been a support weapon for infantry. Any weapon designed to support infantry had to move with them, and for most of the last century, infantry moved by foot. This meant machine guns had to be as light as possible. Size and weight became a major consideration in any new gun design. Another portability issue was ammunition. The amount of ammunition available for a machine gun was limited to whatever the soldier could carry. Subsequently, nearly all machine guns were designed to fire at the economical rate of 550 to 800 rounds per minute. In this way, the limited supplies of ammunition carried on soldiers' backs could be made to last. The M60, M240, and even the M249 are all descendants of this design philosophy. However, the environment which helped to create these machine guns has changed. In the 21st century, the Western way of war is almost entirely mechanized. and as such, vehicles are everywhere. From Humvees and Strykers to Blackhawks and Chinooks, today's soldiers drives or flies to work. What has not kept pace with the changing nature of warfare is the choice of machine guns deployed on vehicles. With the sole exception of the Special Forces, soldiers still rely on slow-firing weapons that were designed for another era. Current weapons such as M240s and M60s, weapons that were designed for the foot soldier, are widely deployed on ground vehicles and helicopters. What is needed is to recognize that our forces need more effective firepower that is currently in the inventory and available. It is the abundance of vehicles that makes it possible to have more ammunition and larger weapons at their disposal. Gatling guns with their large ammunition capacities, high rates of fire, and tremendous suppressive fire abilities make them the ideal choice for any gun truck or helicopter. Someone once said, "He who shoots the most, the fastest, wins." He was right. The standard Dillon Gatling gun fires 3,000 shots per minute. That equals 50 shots per second. No other 7.62 millimeter weapon comes close to this rate of fire. Fast guns achieve the extreme shot densities that allow the suppression of multiple targets in compressed periods of time. More importantly, fast guns are more accurate than slower firing weapons. There are two reasons for this, and both are a result of high cyclic rate. First, Gatling guns experience virtually no recoil. The M134D fires 50 shots per second, meaning there is 1/50th of a second between each shot. Because the time between shots is so small, the M134 on a properly engineered mount simply moves aft with the first shot and stays there, with no tendency to pitch up or yaw. This makes the weapon far more stable. Due to its rotary design, the M134 experiences low mechanical vibration. This compares favorably to the M240 and .50 caliber, in which the linear motion of the gun bolt induces a considerable amount of vibration, interfering with aiming. Additionally, for every one round fired from an M240, there are 4 rounds fired from the Gatling. This makes for very dense shot grouping, not unlike a shotgun. A third way in which fast guns are more accurate comes in the form of reduced error correction. When a gunner fires on a target, he must see the impacts to know exactly where the gun is aiming. The amount of error can grow quite large due to helicopter movement, gun movement, and target movement. As the range to the target increases to 100 meters or more, the problem gets severe. However, by increasing the number of shots per second, the amount of time between each observed impact is greatly reduced. It is in target saturation that the Gatling gun truly excels. Earlier, we said that the M134D was almost 10 times more likely to hit its target than typical gas-operated guns. That's a pretty bold statement. Well, now we are going to prove it. In this demonstration, an M240 is used to strike a simulated exposed target. The gunner will fire 10 seconds or 130 rounds. We will then score the results. Let's watch. Now, the Dillon M134 will shoot for the same 10 seconds at a duplicate target. Let's look at that again. This time, pay close attention to the density of impacts. So, what was the result? The M240 scored 12 hits. The Gatling gun? More than 110. That's a 9-to-1 hit ratio in favor of the M134. Even if the target is not hit directly, the target may still be suppressed by the amount of debris that is thrown into the air. Clearly, shot density is the name of the game. Since Gatling guns are more effective and more reliable than conventional gas-operated guns, fewer weapons are required to cover a target area. Fewer guns mean fewer bodies to man them, and fewer platforms to support them. This translates into big cost savings. The Dillon M134D is a true